Hello everyone. In the last class we have discussed about the three different properties of rational numbers, that is the closure property, the commutative property and the associative property. Today we'll be discussing further on it. So the next is the role of 0. So what is the role of 0? Let us see. If we add 0 with a rational number in any order, the resultant number that we get is the rational number itself. Say for an example, this half is a rational number, and if we add it 0 either in this manner or in this manner, whichever order you want to say, we will always get the number itself. Even in this case, in case of a negative number, negative rational number, if we add with 0, we'll get the same number itself. So 0 is called what? 0 is called the identity for addition of rational numbers. Now you might be thinking that is it possible with subtraction? The answer will be, what do you think? The answer will be, not maybe I'll say, the answer will be definitely not. Because say in this case, if I put a subtraction over here, then what do you think? The answer will be plus 3 by 5. So definitely it is not the same number as that of the earlier case. The number was minus 3 by 5, but we'll get a number in the result as plus 3 by 5 if we put a minus over it, because minus minus it will be plus. So it holds only for the addition of rational numbers, not for the subtraction of rational numbers. Now moving on, the role of 1. If we multiply 1 with a rational number, obviously the resultant number will be the same number. This is very clear to you all. Same example I have taken, just I have multiplied in any order, either in this order or in this order, the answer will be same as it is. So 1 is called the multiplicative identity for rational numbers. Now moving on, the negative of a rational number, or it is also called the additive inverse. You have already learned about additive inverse in your last class, in class 7, in the chapter rational numbers. So it is written here, if we add a rational numbers with its additive inverse in any order, the resultant number that we get is 0. So this is, say this is a number, rational number half, its additive inverse will be minus half. So whenever we add a rational number with its additive inverse in any order, the resultant number will be 0. It is always, whenever we add a rational number and its additive inverse, the resultant answer will be 0. Now moving on, the reciprocal of a, or you can say also multiplicative inverse. We all know what is reciprocal. So if we multiply a rational number with its reciprocal, the resultant number will be 1. So for example, if we have a number half, so its reciprocal will be 2 by 1. Although we can write 2 by 1 as 2, but we have to write in the rational number form, p by q form. So the answer will be always 1. Here also minus 3 by 5, its reciprocal will be 5 by minus 3. Now you might be saying, sir, why it is not minus 5 by 3? No, it will not be minus 5 by 3, it will be 5 by minus 3. Reciprocal is just the opposite of that. So whatever it is, whenever we take the reciprocal of a rational number, the answer that we'll get is 1. But 0, does it have any reciprocal? No. 0 has no reciprocal. Okay. Now moving on, the next property, there is a distributive property. There is the last property for rational numbers, distributive property. So distributive property holds in case of addition and subtraction only. So in case of addition, if you see, when we multiply a sum of rational numbers by another rational number, it equals the same result when we multiply. Okay, but just by reading the definition, it may be not clear to you. But if you look carefully at the definition as well as this form, it will be very clear to us. Here it is written, when we multiply a sum of rational numbers. So B and C are two rational numbers and its sum, when we multiply with another rational number A, then we will get this form, that is, which equals the same result when we multiply each of the rational numbers by that rational number and then add the products together. So here it says we'll get the same result. Whatever result we'll get here, it will be the same on the right hand side also when we multiply each of the rational numbers. These are the rational numbers B and C with that rational number A, that is A into B plus A into B and B into C, and then take the and then add the products of that two resultant rational numbers. So then we will get equal value. So for proving this, let us first take some example. In place of A, we have taken minus 3 by 4. In place of B, we have taken 2 by 3. And in place of C, we have taken minus 5 by 6. Now, if you see carefully, here, if you do this multiplication, how to do is, we all know, according to BODMAS rule, first of all, we will take what is inside the bracket. So we will solve inside the bracket, taking the LCM, that is 6, then doing the calculation. Then we will get the answer as 1 by 8. Yes, multiplication is very simple, just numerator and denominator. Now in the RHS, we have this form. So we will do in this form itself. So this is the number. What we did is, we multiplied minus 3 by 4 with 2 by 3. And again we multiplied minus 3 by 4 with minus 5 by 6. And then took the sum of these two numbers. So let us see if we get the same number. Yes, we got the same result. So LHS here is equal to RHS. So that's what we needed. So the distributive property holds for addition. Similarly, if we do in subtraction, nothing is different here. Just only in place of plus, it will be minus. So I have taken the same example. And here also the answer holds. You can see in the LHS we got minus 9 by 8. In the RHS also we will get minus 9 by 8. So both the sides are equal. So even in case of subtraction, this distributive property of rational number holds. So I hope you all have understood this much. Now I would request the students to kindly go through the next examples as well as do exercise 1.1 in your copies. And if you have any doubt, do inform me in the classroom. And please go through these properties very well and then use these properties in the sums that have been given in your book. So that's it for today. Thank you and have a nice day.